Okay, so the doctor orders half-strength formula feeding. Basically, the patient can't tolerate a full-strength formula. Maybe it's because it's a new feeding. So the doctor orders a half-strength formula. And the can in the pantry, right here is what it might look like. It's full strength, and it has 250 milliliters in it. So the doctor says, I want you to give your patient longevity feeding, but only give half strength. That basically means you have to dilute it. You have to dilute this full strength formula because maybe it's too harsh on the stomach for the patient right away. So you go to the pantry and there's a can that has 250 milliliters in it. So the question is saying and asking, how much water will the nurse add to the can to make it half strength? The doctor says it needs to be half strength. So the dimensional analysis way is, well, I walked in and there's a can of formula, 250 milliliters in it, and the doctor ordered half strength. So I'm solving for milliliters, and I'm going to tell you, can anybody tell me why I'm solving always for milliliters when it comes to feeding?
Because it's liquid.
Because it's liquid and it's part of your intake and output. Intake and output questions, intake and output calculations in the hospital is always in milliliters. The answer must always be in milliliters, okay? So it's always solved in milliliters. So how do I get rid of this and only have milliliters? Well, that's where the formula comes in. To get rid of a half, I can add a half up here because a half and a half is a whole and I can cross it out. So now I multiply across the top. 250 times 1 is 250. 1 times 1 is 1. So what's my answer? 250 milliliters. So basically this is saying I'm going to add 250 milliliters into this 250 milliliter can to make it half strength. Well, how do you do that? How do you add that all into this little can? Well, in the hospital, they give you these bags. So I'm going to pour the 250 in here of formula, and I'm going to pour the 250 of water in here, and it's going to dilute it to half strength. So now for the simple method. And the reason we teach the formula method, because sometimes, depending on where you work, they'll ask you to do a quarter strength, but I'm not going to ask you that. I'm strictly asking you 50% or half. So this is how I want you to do it. The doctor orders half strength formula. It comes in a 250 milliliter can. Oops. Half strength, 250 milliliter can. What is my wanted? How much water will the nurse add to the can? We know we're solving for milliliters. So I have 250 milliliters. And I'm solving for what? Milliliters. Sorry. Right? So that's the way, dimensional analysis way. This is the way I want you to do it. I have a can with 250 milliliters. I have to add 250 milliliters of water, right? The same amount. 250 plus 250 water. So this is 250 formula and 250 of water. So the question is asking, how much water are you going to add to the can? What's the answer? We just did it.
250 milliliters.
The answer is still 250 milliliters. I'm adding the same amount. So that's simple, right? What about this one?
The same.
So what's the answer you're going to write in the answer line?
350 milliliters.
350 milliliters. So 50% is still half strength. The formula comes in a can with 350 milliliters. How much water will the nurse add to the can? So the can of formula is 350 milliliters. To make it half strength or 50%, I have to add the same amount of water. The question says, how much water will you add to the can? The answer is 350 milliliters of water. That's your answer. So that's simple, right? Can you guys understand that concept? You're basically diluting it with the same amount. That's how you make it half strength. But I'm not going to ask you something that easy. Come on now. You're going to be nurses. I'll give you a minute to solve this. All right. Teresa, check your math. That's good. Good. All right. So it's still asking me to give half strength, right? I got to dilute some formula, but I go in the pantry and the can says 4 ounces. Professor K, you're so mean. It's 4 ounces of formula, right? 4 ounces of formula. And the question says, how many milliliters of water will you add to the 4-ounce can to make it half strength? I'm going to add the same amount of water. So I'm going to add 4 ounces of water. But intake and output is always done in milliliters. So I know I'm adding 4 ounces of water, but I got to convert my ounces to milliliters. And that's where dimensional analysis comes in. And that's where memorizing your equivalents come in. So I start with what's given to me, the 4 ounces. I put that in the numerator position. I put a 1 under it because I got to have balance in my life. And I'm solving for what? I need milliliters of water. Make sure milliliters is in the numerator. And now, how do I get rid of ounces? Well, I got to think, what's my conversion? I should know by now 1 ounce is equal to 30 milliliters. I'm going to use it in my problem. 1 ounce, 30 milliliters. Cross off my ounces. I have milliliters. That's all I need. Everything else is crossed off. Now it's just math. So 4 times 30 is 120. 1 times 1 is 1. My answer is 120 milliliters of water. Boom. Life is good. Now we're getting nursey on this question. Patient was doing good. They were tolerating full strength. All of a sudden they get diarrhea. You call the doctor. Hey, doctor, patient developed diarrhea. He says, all right, we got to cut the full strength formula into half strength formula. And what you have in your pantry, or maybe what dietary delivers, is an 8-ounce can. So the question is still asking you, how much water will the nurse add? Charlotte's on a roll. Stephanie's on a roll. Oh, yeah. Oh, Christian. Christian, do we answer in ounces? Oh, no, we don't. We answer in milliliters. Josh, you forgot the unit of measure. You know you lose 5 points for that, right? If you just put the answer in numerical and not in the unit of measure, because it's what? So the answer is 240. But if you forget milliliters, you lose all points because 240 what? Turtles? I don't know. It could happen. 240 turtles? I don't know. 240 unicorns? Maybe. Yeah, don't realize that after the exam you hand it in, all right? Don't forget your unit of measure. All right, so yes, Christian, you got to remember, ounces, no, milliliters, yes, it's part of intake and output. So I go to the pantry and there's an 8-ounce can of formula of Jevity. And the doctor's like, change it to half strength. So you're going to add 8 ounces of H2O. But it's part of intake and output. So 8 ounces. I'm solving for milliliters. Make sure that's in my numerator. And then I got to do my conversion. 1 ounce is 30 milliliters. Cross off my ounces. I have my milliliters. 8 times 3 is 240. 1 times 1 is 1. My answer is I'm going to add 240 milliliters of water. Beautiful. But guess what? There's another way that you're going to be asked questions about intake and feeding. So I want you to read this question and solve it for me. Good, Josh, you got it. Good, Christine, got it. Good. Okay. Stephanie, yeah, wait. Everybody's going, it's coming back. It's coming too fast. Yes, good, good. All right. So good. You didn't get razzled and dazzled. Hi, oh, you're at work and you're listening and writing notes. I wanted to ask, will we have access to the recording? Yes, I'm recording it. And as soon as Zoom gives it back to me, which I can't promise they will, but as soon as they do, I can post it onto the YouTube site because our emails won't allow me to send the large file. All right, cool. So you didn't get frazzled, razzled, and dazzled with all the extra wording in there. It just basically means the doctor still ordered 50% half strength. It happened to be running already at a certain rate. But what did the question ask? It just asked you how much water will you put in it to make 50% strength feeding. So it's the same thing. You're adding the same amount of formula that's available. 6 ounces times 1 ounce is 30 milliliters, and that is equal to 180 milliliters. But what if I asked you what the total volume is the patient received? Ooh. Stephanie knows. Oh, Charlotte knows too. Yes, good, you guys. This is how simple it is. You started with 6 ounces of formula. You added 6 ounces of water. The total volume of feeding the patient will receive is 6 plus 6 is 12 ounces. So what do? I convert it to milliliters. 1 ounce is 30 milliliters. Cross off my ounces. 12 times 30 is 360 milliliters. Do this one. Good. Yep. Stephanie, Josh, good. Carmen, Jency, good. Esther got it. Good. So what is the question asking you? You got to read your questions. And this is you're gonna hear me say this through your entire semester. Really, nope, that's the volume of water. No, it's asking total volume. So let's do it together. Don't get discouraged. The doctor orders 50% strength. Yes, I will wait. Yes, you got it, Girly. All right. So the doctor orders 50% strength, meaning half strength, basically. And all that's available is an 8-ounce can. So we got a can, it's got 8 ounces of full strength formula in it, and I need to make it half strength. So I'm going to add equal amounts of water. I'm going to add 8 ounces of water. So it's asking me total volume. Well, if I'm adding these two together, the total volume is 16 ounces, right? But everything is in milliliters because it's part of intake and output, milliliters. So it's the same conversion, 16 ounces, 1 ounce is 30 milliliters. I have my milliliters, beautiful, 16 times 30 is 480. So the answer is 480 milliliters. Now, a lot of people will do, they'll convert the 8 ounces to milliliters first, because they like to do that. That's fine. I don't care. Just show me your work. I don't care if you draw a picture of a can. Show me the work, which you have to show me the work on your exams, and show me how you got there. All right. And this way I can say, all right, I know what's going on here. So the answer for the total volume the patient will receive is 480 milliliters. And it's important to know how to do total volume, because if your patient has something that happens like vomiting, the doctor's going to want to say, how much did he get in total? And how much did he throw up in total? So that matters. So the only types of feeding questions you're going to get are how much water or total volume. Does that make sense? I'll give you another, and then we're going to move on. All right, I think you got it. Looking good. Charlotte, Josh, Carmen, yeah, Esther, yep. Ethan, good. Sophia, good. So you read the question, how much water? Beautiful. Jancy, good. It is in fact 300. So what's the total volume? That's right, 600, not a trick question. So don't get frazzled and razzled and dazzled. If you know what the wanted is, and that's whole dimensional analysis, what is given, what is wanted, and how do you get there, you're going to get the right answer. All right, so let's cruise and move on because we got a lot to cover. Let's talk about insulin and the type of insulin you got to understand. So when it comes to insulin, there's a couple kinds of orders you're going to see. There's going to be standing orders and there's going to be coverage orders. Standing orders means the patient's going to receive it at a very specific time. And that's where learning your abbreviations come in. So if you look at this very first question, this is for insulin. The patient has an insulin order. They're supposed to get a Humulin N, which is a long-acting insulin. They're going to get, the doctor ordered 4 units of Humulin N. And he wants you to mix that with Humulin R, 4 units, AC meals. What does AC mean? Before. So if you're reading an order and you go to give your patient this insulin and it's, I don't know, midnight, you're making a med error because the order says before meals. So that's why understanding abbreviations and how they're used in questions is so important. That's why you have to read everything, especially when it comes to doctor's orders. So this question says, ordered Humulin N 4 units. So I'm giving Humulin N 4 units, and I'm mixing it with Humulin R 4 units before meals. At 12 o'clock, the patient's finger stick was 149. Because if you look here, what do we got? We got the doctor ordering special coverage orders. Now, coverage order is based on the patient's finger stick. So at noon, which is lunchtime in the hospitals, the patient's finger stick was 149, and these are the coverage orders. So basically, you have to say 149 falls where in these ordered coverage orders? Well, 149 falls where, right? Here. So the patient's finger stick was 149. And this order says less than 150, no insulin. The question says, what is the total amount of insulin the patient will receive before lunch? What's your answer? Yes, it is 8. Because we're still going to give the 4 of N, the 4 of R. but he didn't require any coverage in addition to that. Now, if I said at noon, his blood sugar was, oops, just stop writing. His blood sugar was 290. He would get 4 units of N, 4 units of R, and 6 units of additional, because 290 falls here. So it's about reading the question and just identifying where they fall in the order. Let's do another. I'm going to pause and let you figure this one out. All right. You guys are getting it. No worries. Yes. Teresa, you got a couple things written there. What's the total? Give me one number. On your answer sheet, I just want one answer. Okay. So what's the total? It's asking you to right on. 30 units is the total. So let's do it together real quick. The doctor orders, standing orders, Humulin N, 12 units, Humulin R, 8 units before meals. At 7 a.m., that's before breakfast. The patient's blood sugar was 348. Well, that's good because the doctor ordered additional coverage. So the additional coverage is all of this. So where does 348 fall in all this additional coverage? Well, it falls right in here, 10 units. So I'm going to start with 12 units of N, 8 units of R, and now I have to give an additional 10 units. So the answer is 30 units. And that's how you do the insulin questions. Now, of course, there's much more related to insulin than this, and you'll learn that throughout the program. Will we always be provided with the coverage units? Yes, if it's asking you for coverage, yes, you'll be given the coverage, the orders. And doctors order them differently. They're not always the same for patients. So you'll be given the parameters. These are the parameters and how much to cover with the insulin. And then you'll be given the answer at 348. Now, when you're working as a nurse, you're going to take the finger stick and look for parameters. If there are none, you're going to call the doctor and say, listen, you got standing orders for 12 and 8 units of this and this and that, but his sugar is still 350. Do you want to add any regular insulin? Cool. All right, let's do another. Charlotte, I got something different. Yes, Ethan, good. Talia, yes. Charlotte, yes, good, good, good. All right, yes, you're getting it. Fine, beautiful, love it. All right, the doctor says he needs 13 units of N, which is long acting, 11 units of R before meals, and AC. And what's HS?
Hours of sleep.
Yeah, hours of sleep, which is bedtime. So AC and HS. No worries, we got this. So we're going to give 13 units of N, 11 units of R before meals and at bedtime. And this is happening at 2100. So maybe this is bedtime, I don't know. But his blood sugar was 202. Where does 202 fall in this coverage order right here? So he's going to get an additional 6 units. Oops. So then I just add it all up, and that's 30 units. Beautiful. All right, one more, and then we're moving on. Do it. You got it, Sophia. Good, Steph. Good. Charlotte, good. Teresa, yes. Josh, yes. Good, good, good. Talia, yep. Sandra, yep. Shanti, yep. I think you got it. Yes, 22 units. You got it. Excellent. All right. So it's just about reading the question and not making silly math mistakes. All right. That's really what it is. So again, we're going to start with 7 units of N, 5 units of R before meals and at bedtime. So the timing correlates. All right, cool. The doctor ordered coverage with additional Humulin R. So the patient's finger stick is 303. 303 falls in here. So we're going to give 7 units of N, 5 of R. That's our standing orders. And then an additional 10 units of R. So we just do the math. So it's 22 units. Beautiful. Congratulations. You got 5 points. Just don't make a silly mistake. All right. Give me 1 second. I just got to move to the next PowerPoint. Real quick, do this one while I'm getting myself situated. Yeah, good stuff. Yes, Francine, Teresa, Sophia. Yes, it's not a trick. It comes in 100 milliliters. How many milliliters of water will you add to make it half strength? I'm going to add the same amount, but it only wants to know how much water. So I'm going to add, my answer is 100 milliliters of water. Beautiful. What about this one? How many milliliters of water will you add? So basically 5.5 ounces is what I'm going to add. The can has 5.5 ounces. I convert ounces to milliliters because for intake and output, we always do milliliters. So it's 30 milliliters. So ounces cross off. I have milliliters. So 5.5 times 30 is 165 milliliters. Pew, 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 pew. What about this one? Babies get fed too. Babies need food too. Some of you may work in a NICU. Yeah, it's not a trick. Still the same process, 25 milliliters. They want half strength Enfamil for this little NICU baby. Yes, Amanda, I'm going to post it to the YouTube site because I can't email the thing. I'll also try to post it to the Google Drive, the recording. All right, so it's not a trick question. It's the baby's Enfamil comes, the doctor says 25 milliliters, make it half strength, you're gonna add 25 milliliters. So the total volume is beautiful. All right, now we're going to move on to one factor. And this just basically means the order has one element to it. They call it one factor. That means there's just one part for the doctor's order. And this is a more dimensional analysis. So I'm going to let you guys try this one. I'm going to give you a minute. Yes, Stephanie. Yes, Charlotte. Good. Good, Jancy. Yes, girly. Good. Sophia. Yep. Good, Teresa. All right. All right, you rock stars. I love it. So let's do this dimensional analysis. Wait, yes, Esther. Very good. All right. So I always start with the given, which is my doctor's order. And it's a one factor because there's one element to the doctor's order. The doctor ordered 750 micrograms of a medication. Because it says prescribed. That's how I know it's the doctor's order. On hand, which means what's available, is a bottle labeled 0.5 milligrams per milliliters. What am I going to give? Well, right away, I have micrograms ordered and it comes in milligrams. So I need to think I need to do a conversion. And what am I solving for? Well, if it's coming in a liquid, I'm solving for the liquid. I'm not going to walk in and give my patient a capsule because it doesn't come in a capsule. So I'm solving for milliliters. All right, and make sure that's in my numerator. This is my denominator. So 750 micrograms, I start in my numerator. I always put a 1 under it because I just need to see that. Now I need my conversion. Well, I know that 1 milligram is equal to what? 1,000 micrograms. So I'm going to use it because I don't need micrograms. I need milliliters. So I got to get rid of micrograms. So 1 milligram is 1,000 micrograms. That crosses off my micrograms. Beautiful. But now I have to get rid of milligrams. So how do I get rid of milligrams? I'm going to use what's in my problem. 0.5 milligrams per 1 ml. And I put it this way because anything diagonal, I can cross off as equal. So now I've gotten rid of my milligrams, I've gotten rid of my micrograms, and I have milliliters left. And that's exactly what I need, only milliliters. So now I'm ready to solve. And this is where it's just math. So 750 times 1 is 750. 1,000 times 0.5 is 500. Then I divide 500 into 750. And when I divide that, and this is where your calculator comes in. So I'm going to go 750 divided by 500 equals 1.5 milliliters. Oops, milliliters. That's what I'm going to draw up and give to my patient. It could be an injection, could be a liquid for a baby. I don't know what it is. But either way, you have to make sure you're given the correct unit of measure. Let's go to another one. I'll give you a minute to solve. Yes, Stephanie. Yep, girly, good. Yes, Charlotte, good. Jancy, yes. Sophia, you forgot the L. Don't do that on the exam. Esther, yep. The unit of measure is so critical. Yes, yes, yes. Good, good, good. Sophia. Question, okay. What's your question, girly?
So I was doing the review. On the test, would you put round this to the nearest? Because there are some question that I did, which is originally was correct, but they want me to round it. I know how to round. It's just like, would you give that on the question or before the question, round to the nearest tenth?
No, it's part of
Or-
the requirement. That's part of what you have to memorize is the rounding rules. That's what's on the exam, the direction.
Right, but when do you round it? Because again, I was practicing.
You always round until when you get to the very end of the question.
Okay, so I gave you the answer, right? That is it 3.6, right? So do you want me to round that to 4
No,
or
no.
just leave it 3.6 ml?
Numbers between 1 and 10, you round to the tenths. So numbers between 1 and 10, 3 is between number 1 and 10, right?
Right.
So if this said 3.6, if your answer came out to 3.633, right?
Yeah,
Numbers
leave it
between 1 and
3.6.
10, you round to the tenths. So I look to this number. The answer is 3.6. This is the 10th spot.
Right. I get that. I know how to do it. It's just that again, there's this question that I have to round it, but it does not indicate it for me to round it. It does not say on the question to round it.
No, I won't say it on
My
the question.
question to you is, would that be automatically that I have to round it?
Yes. It's part of the directions. It was in the packet. Part of the directions for every exam, which you will have access to when you sit for your exam. It's the first page. It tells you the rounding rules on it with examples. And that was in the registration packet as well.
Okay,
The
I just
rounding rules are
remember-
very important. But if you make a rounding error, it's only a 1-point deduction. You know what I mean? So if it's a rounding error, you will lose 1 point.
So if that means, in other words, if I don't round it.
But let's say the answer was 3.633 and you wrote 3.7.
Oh,
you-
no. Okay.
No,
Okay.
if you improperly rounded, you would only lose 1 point. If it was 3.633 and you rounded to 4, but if I see your work, this is where putting your work in is so important. But if I see you rounded incorrectly, I would only take away 1 point.
Okay.
Okay?
Understand. Thank you.
No problem. So yes, what is the answer to this question? So everybody put in well, the answer is 3.6. So let's do it real quickly together. So the medication is ordered, that's the doctor's order. Ordered is 0.5 grams. PO, what does that mean?
By
Good.
mouth.
By mouth. Don't try to inject this, it's by mouth. That's where critical thinking in nursing comes in. If you don't read the answer and you're trying to draw this up into a syringe, whoo. So I already know. What am I going to give? Well, it's in a liquid form, so I'm going to give that milliliters by mouth. Put that over 1. So I have grams and available is milligrams. So I need a conversion. So I know 1 gram is equal to 1,000 milligrams. So I'm going to get rid of grams by using my conversion. 1 gram is 1,000 milligrams. That crosses off my grams. Now I got to get rid of milligrams because I need milliliters. So I'm going to use my problem now. So 500 milligrams in 4 milliliters. Beautiful. Get rid of my milligrams. I'm left with milliliters. Everything else has been crossed off. I'm ready to solve. So now it's just math. So 0.45 times 1,000 times 4 is 1,800. And 500 times 1 times 1 is 500. So when I divide 500 into 1,800, it will give me, I'll do the calculator, 1,800 divided by 500 is 3.6 milliliters. And anything between 1 and 10 is rounded to the tenths, and this is already there, so I'm good. My answer is I'm going to give my patient 3.6 milliliters in a little medicine cup, or if it's a kid, in a little oral syringe. Piece of cake. All right. Let's do tablets. Now on the tests, here I just wrote it, but on the test you will have a picture and it'll tell you if it's half scored, it will look like a photo of it'll be a picture of a pill. All right. And this basically means when it's scored, it means I can break this one in half. All right. And that's what that means. So this question is a half scored tablet. So I'm going to give you a minute to solve. Correct, Teresa, correct, Esther. Good. And you wrote it the right way, Esther. Thank you. Correct. Very good. Very good. Yes, good. Good, Stephanie. Good, Jancy. Good, Sophia. Yep. Josh, check your setup. Charlotte, I don't think you can give it that way, but we'll talk about it because it's only breakable in half. Cheyenne, yep. All right, let's do it. Josh, nope, we're gonna do it together. Let's go. So what's my given? My given is my doctor order. And he said a dose of 0.25 milligrams is prescribed. The word prescribed means ordered, right? So I'm starting with the doctor's order, 0.25 milligrams. Beautiful. So what am I giving? Well, it comes in a tablet, so I'm giving a tablet. So my wanted is tablet. I'm going to put that over 1, make sure the word tablet falls in the numerator section. That's why I write this way. So 0.25 milligrams is ordered. But guess what? Available is only 500 microgram tablets, and it comes split in half. So I need to know my conversion. So 1 milligram is 1,000 micrograms. And I'm going to use that in my problem. So I got to get rid of milligrams and get the tablet. So I need to get rid of it. 1 milligram is 1,000 micrograms. Beautiful. Got rid of that. Now I got to get rid of micrograms. How do I do it? I'm going to use what's in my problem. So this is where I think some of you got mixed up. 500 micrograms in 1 tablet. This is just telling you how it's scored. You're not using that in the problem, okay? It's just saying you can break the tablet in half. So now I get rid of my micrograms and I'm left with tablet in my numerator. That's exactly where I need it. Everything else is crossed off. Now it's just math. So 0.25 times 1,000 times 1 is 250. 1 times 500 is 500. Now I'm going to divide, if I did old school, 500 into 250. But that's why you got a calculator. So when I divide 250 by 500, it will give me, on my calculator, 0.5. So my answer is the patient will get 0.5 tablets. Now, some people wrote half a tab. That's correct too. So I will accept half a tablet written like this, and I will accept 0.5 tablets written like this. Now, if you happen to write, let me just make room here. If you write 0.5 tablets, why would you get points taken away? Yeah, you need a 0. When you have something less than 1, this could be mistaken for 5. You need that leading 0. If you accidentally gave a neonate 5, let's say if it was milligrams, or 5 micrograms instead of 0.5, you've given 5 times the dose, which is lethal with some medications. Some medications slow the heart rate. If you give 5 instead of 0.5, you could stop their heart. So that's why it's very important. So when you have a number less than 1 and there's a decimal, you have to have that 0 in front of it so we don't make an error. And the same is true if the answer was 5 tablets and you wrote 5.0. Why is that wrong? Because that could be mistaken for 50 tablets or 50 milliliters or 50 milligrams instead of 5. So knowing those zeros and where to put them, just as important. So basically, you're going to get a medicine cup. And that's why it's important to know if it's broken in half or quarters. Somebody had answered 0.25 tablets. Well, this tablet can't be broken up in quarters. So it's either half or a whole or 1.5. So you're going to break this in half and the patient's going to get half a tablet in the cup. All right. Now, this is just another example of another type of equivalent. They're called milliequivalents, but I'm going to give you 1 minute to solve. Charlotte, I like how you wrote both. What is it, Charlotte? Jency got it. Teresa, what'd you forget? What'd you guys forget? I mean, it's only 1 point. I mean, what's the point? What's a meta? No, I'm kidding. What's the point? Yes. Don't forget your rounding rules. Correct. You got it. Good. All right, let's do it because we are running out of time. So what is my given? Oh no, yes. So my given is the doctor's order, and it says right there, ordered 30 milliequivalents. And this is just a type of unit of measure, and it's usually the potassium that you'll be giving in your practice. So 30 milliequivalents, the doctor orders. What am I going to give? Well, it comes in milliliters, and it's a liquid, so I'm going to give it as a liquid. I put that over 1. This just reminds me the unit milliliters has to end up in the numerator position. So how do I get rid of milliequivalents and get to milliliter? Well, I'm going to use what's in my problem. So 20 milliequivalents in 15 milliliters. That crosses off my milliequivalents and it leaves me with milliliters, just what I need. Now it's just math. So 30 times 15 is 450 and 20 times 1 is 20. And when I divide that into 450, it gives me 22.5. But our rounding rules say 10 and up, we round to the whole number. So 22 is over 10, right? So I round to the whole number. I look to the number to the right. 5 and up, we round up. So my answer is 23 milliliters. Now, if you're getting all flustered during your exam and you leave 22.5, it is only 1 point deduction. I take the 1 point hit instead of a 5 point hit any day of the week, but just thinking strategically. All right, so 23 milliliters of probably potassium chloride the patient will get, and it tastes disgusting, and they'll complain. But we're going to give it. We're going to support them. All right, I'm going to move on to, let me see. I want to just go over. Where is my? Sorry, bear with me. I'm trying to find it. Well, I thought I had capsules on here. All right. I'm going to just change this to capsules, just so I can talk about capsules, okay? So I'm going to give you a minute to try that. So question, if the value was 9.5. Yeah, you would leave it 9.5 because it's a number between 1 and 10. If you got an answer that said 10.4, well, 10 and up, you round it to a whole number. So 10.4, the whole number, you don't round up if it's under 5. So the answer would be 10. If you got 10.5, the answer would be what? 11. All right, Charlotte, Stephanie, Esther, yep. Good. Good. The one thing I want you to remember about capsules, and it's very important. First, let's do the problem. So the doctor ordered 1 gram of Oronase, available as milligrams, and we're solving for capsules because that's how it comes, capsules. Good. Yes, Cheyenne, you got it. Carmen, yep. Sophia, yep. Josh, got it. Good. All right. It comes in, it's ordered in grams and it comes in milligrams. So we need a conversion. 1 gram is 1,000 milligrams. And there's 500 milligrams in every capsule. So I'm going to cross off my unwanted That is how dimensional analysis works, and I'm left with capsules. And now it's just math. So 1 times 1,000 is 1,000, and 500 times 1 is 500. When I divide that into it, it is 2. So I'm going to give 2 capsules. But what I wanted to talk to you about is, what if your answer came out to be 1.75 capsules? What do you think the answer would be? Yes, Esther, you're right. Yep, Ethan, you're right. It's still 2 capsules. Why? Why are you not following the rules, Professor K? You said we have to follow the rounding rules. Well, you can't split a capsule. Because when you open up a capsule, which you should not be doing, if you do practice as an LPN, I don't want to hear about what you do, but capsules are not meant to be opened. So either you're going to give, if you have an answer that says 1.75, you have to make a decision. Either you're going to give 1 capsule or you're going to give 2 capsules. And where does 1.75 end closer to? Well, it ends closer to the 2 capsules. All right. So that's the rule about capsules. You cannot round it. You can't split it. You can't break it open. You got to either give, you always have to give a whole capsule. So you have to make a decision. Okay. And that's where showing your work is important. All right, good. So that was basically the 1 factor. This is how you do 1 factor. There's one thing I want to show you about mixing. Hold on. Oh, good. Okay, number 11. This is called reconstitution. So I want you to try this, and then I'll do it with you. Correct. Correct, Stephanie. Correct, Charlotte. Yep. Girly, what's your unit of measure? What are you administering? Yes. Good. Yep. Sophie got it. Nancy got it. All right. Yes. Good, good, good. Carmen, check your math. I know what you did. I guarantee I know what you did. I think your setup was mixed up. That's okay. Esther, I got a different answer, but we'll do it together. So we're going to check our math together. So first things first, what is the doctor's order? Teresa, I got a different answer as well. So what is the doctor's order? Where are we starting? What's our starting point?
50,000 units.
Absolutely. The doctor ordered 50,000 units. This is probably some crazy antibiotic. I'm going to put that over 1. And what is my wanted? Well, how does it come? It's going to come in milliliters. So now what does this mean? It's supplied with 250,000 units, and it tells me to reconstitute it. All right. Well, basically what this means is this. They're going to send you a bottle, and it's going to have powder in it. And it's going to say 250,000 units of powder. All right. I can't give that. It's in a vial. How am I going to give that to the patient? Well, the directions say you're going to reconstitute it. Means you're going to dilute it with 10 milliliters of whatever fluid they order, saline, water, whatever it is. So I'm basically going to put 10 milliliters into the vial, and then I'm going to mix it up. When all is said and done, this is basically just saying there's 250,000 units in the 10 milliliters I just put in it. So basically it's giving me my conversion. Because I added this to the vial, it's now a liquid. So I have 250,000 units in 10 milliliters. I'm using that in my problem all day because I got to get rid of units and I got to get to milliliters. So let's do it. 250,000 units in 10 milliliters. So I cross off my units and I'm left with milliliters. Now here's the rule of zeros. Now you can use your calculator. 50,000 times 10 is something gross. I'm sure of it. I cross off zeros, but let's do it. 50,000 times 10, my calculator probably won't even go that far, is 500,000. And then 250,000 times 1 is 250. So when I divide 250 into 500,000, it will give me 2 milliliters. But there's another way you can do it. You just have to be careful. I like to cross off my zeros. So I'm going to cross off 1, 2, 3, 4, and the same on the bottom. 1, 2, 3, 4. All right. So now it's 5 times 10, which will give me 50. And then 25 times 1 is 25. You can do it either way. I don't care. Just get the right answer for your patient's sake. So the math is still the same. It's still going to be what? 2 milliliters. Boop. If you put the wrong unit of measure, it is wrong. You get no points. That's reconstitution. But all the information you need will be in the question. Okay. So that's one factor. Let's talk about two-factor real quick. Two-factor is identical to one-factor, except it adds weight. The patient's weight. Let's see if I can find it. Okay. Oops. Nope. Stand by. Oh, actually, I'm going to let you guys do this one real quick, okay? Yes, Stephanie, good. Yes, Charlotte, good. You got it, Josh. Good. I got a different answer, Ethan. And if I'm saying your name wrong, I'm sorry. Correct me. That's why they call me Professor K, because nobody can say my name. Say my name, say my name. It could be your setup. All right. Let's do it. First, identify the giving. What is the doctor's order? Prepare 640,000 units. If you didn't start here, you're going to get the wrong answer. If you start with the wrong thing, you're going to get the wrong answer. Find the order. So 640,000 units for injection. What am I going to give? Well, if I'm going to inject it, it's going to be in milliliters, right? So milliliters over 1. But now it's saying it's sending me a vial with 1.1 million units. It's definitely an antibiotic. And it's telling me I have to add 8 milliliters of water. So how do I write 1.1 million units? Believe it or not, people get confused. So we write 1.1 million units as 1,100,000 like that. That's how you write 1.1 million units. So I'm adding, so they send me this vial and the vial has, oops, why is it doing that? Ooh. The vial comes to me and it has 1.1 million units and it's all powder. And the instructions say add 8 milliliters to it. Okay, no problem. That just means for every 8 milliliters that I just added, this has 1.1 million units. So that's what I'm going to use in my problem. 1.1 million units in 8 milliliters. I cross off my units. It leaves me with milliliters in the numerator position. That's just what I want. Now it's just math. I got to cross off some zeros though. There's too many going on here. So I've got 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. So now 64 times 8, or you can do it the long way. I'm going to do it the short way. 64 times 8 is 512. And 110 times 1 is 110. So 512 divided by 110 gives me 4.6545. And it goes on and on and on and on and on. But what's my rounding rules? Any number between 1 and 10, 4 is definitely between 1 and 10. I round to the tenths, right? So I look to the right. It's 5 and up, so I'm going to round this number up. The answer is 4.7 milliliters. I'm going to draw that up into a cup or a syringe. I don't know. Well, oh, it says inject it. I'm going to draw it up into a syringe and I'm going to inject it into my patient, probably in 2 different doses. That's a large amount, but just another, I just want to review reconstitution. All right, let's go right into 2-factor. All right, this is 2-factor, meaning there's 2 elements to the doctor's order. Can you find it? What is the doctor's order? Administer 0.2 milligrams per kilogram intravenously every 6 hours. My order is 0.2 milligrams per kilogram. How do I write it? 0.2 milligrams over kilograms. Numerator, denominator. And the question says, how many milliliters will you administer? I'm solving for milliliters. If you always set your problems up like this, I promise you, you'll get them right. Because it's about eliminating the unwanted. So I'm also cool with you crossing off. Mark up the test. Do what you got to do. So the doctor ordered milligrams, but it's available in micrograms. So I got to be thinking 1 milligram is 1,000 micrograms. I got a patient weight in kilograms. It's a baby. I got to be careful. So it's just a matter of what do you want to eliminate first? Well, I'll go easy. I'm going to get rid of the kilograms first. So how do I get rid of kilograms in this problem? I'm going to use the patient's weight, 4 kilograms. I'm going to put it over 1. And then that allows me to cross off kilograms. Beautiful. I've used it. Now, how do I get rid of milligrams? Because I only need milliliters. I'm going to look to my problem. The only thing I haven't used is this micrograms, but I do have a conversion. So I'm going to use it. 1 milligram is 1,000 micrograms. Boom, I got rid of milligrams. Now I got to get rid of micrograms. So I've used that. Now I can use what's in my problem. So you see how it's a process of elimination. 800 micrograms in 1 milliliter. Cross off my micrograms, and now I am only left with milliliters, and that's exactly what I need. So you guess it, now it's just math. Sorry, 1 second. Okay, so 0.2 times 4 times 1,000 times 1 will give me 800. 1 times 1 times 800 will give me 800. 800 divided into 800, you got it, Steph, 1 milliliter. I'm going to give my patient, which is a little baby that weighs 4 kilograms, 1 milliliter. So you see how important this is when you do it by weight. So these medications you administer based on the patient's weight. And that's what makes it 2 factors. There's 2 parts, 1 and 2 parts, okay? So I'm going to give you a minute or 2 to solve this one. Yes, Stephanie. Yes, Charlotte. Girly, check your math. Or did you forget a decimal? Teresa, 1 to 10, we round to the tenths. Cheyenne, yes. Esther, yes. You got it, Teresa. Jancy, yes. What are you guys talking about? You know what's happening. You know what's good. All right, let's do it. I'm somebody that likes to mark it up. Oh, what is going on with my iPad here? All right, the doctor ordered 0.5 kilograms. 0.5 milligrams per kilogram. Sorry, just had a brain blip. Pharmacy sends 3,000 micrograms per milliliter. The patient weighs 11 kilograms. How many milliliters will you administer? It's all right there. So I start with the doctor's order. 0.5 milligrams. Put it over a kilogram. Yay. Used it. Solving for milliliters. Yay. Got it. So what do I want to get rid of first? I'm going to get rid of kilograms. Patient's weight, 11 kilograms. Over 1, gets rid of kilograms. Beautiful. Used it. Now this is in micrograms and he ordered milligrams. So what's my conversion? 1 milligram is 1,000 micrograms. Beautiful. Cross it off. Yay. Now I got to get rid of my micrograms. I'm going to use what's in my problem. 3,000 micrograms per 1 ml. Beautiful. And it leaves me exactly with milliliters. That's all I need. Everything else is crossed off. I'm ready to rock and roll. Let's do the math. So 0.5 times 11 times 1,000 is 5,500. And 1 times 3,000 is 3,000. And when I divide 3,000 with 5,500, I get 1.83333. Keeps going. My rounding rules, 1 to 10, any number between 1 and 10, I round to the tenths. I look to that number to the right. If it's 5 and up, I round up. If it's not, keep it where it's at. My answer is 1.8 milliliters for another child. You don't want to mess up medication administration for a child or anybody, but that's how important understanding this concept is. All right, now let's not think I'm going to just ask you these easy kind of questions. I'm going to challenge you to convert. Uh-oh. I'm going to give you a minute to solve. All right, let's do it. So what is my doctor's order? Well, he has ordered 6 milligrams per kilogram. It still means the same thing. It's just written different. It still means 6 milligrams per kilogram by mouth, 3 times a day in equally divided doses. That's part of an order, but you just need to know the strength because we're solving for something. So 6 milligrams per kilogram. How many milliliters will I give? Well, it tells me my wanted. So I've used this. I know my milliliters. So I have to get rid of milligrams and get to milliliters, and I have to get rid of the kilograms. So I can start with whichever. Available is 240 milligrams per ml. So let's start that way. 240 milligrams in 10 milliliters, I'm so sorry, in 10 mLs. I cross off my milligrams and ooh, I got my first part, but I still got to get rid of the kilograms. But the patient's weight is in pounds. That's where your conversions come in. So I have to get rid of kilograms and it's in pounds. So I need to know what? What's my conversion? 1 kilogram is 2.2 pounds. And you've got to be familiar with this because when you're practicing, it's all about the patient's weight in kilograms. So I'm going to put this in my problem to get rid of kilograms. 1 kilogram is 2.2 pounds. I cross off my kilograms. Now I have to get rid of the pounds. Well, that's all right because my patient's weight is in pounds. So now I'm going to use 48 pounds and put that over 1. Gets rid of my pounds. So now I'm good. Everything is crossed off except for my milliliters. Now it's math. So when I multiply across the top, 6 times 10 times 48 is 2880. And 240 times 2.2 is 240 times, is 528. And when I divide 528 into 2880, it'll give me 5.4545. It keeps going. So 1 to 10, I round to the tenths. I look to the number to the right. If it's 5 and up, I round up. So I am going to give the patient 5.5 milliliters. So for those of you who got it wrong, where did you start? Find that error, okay? And then make that tweak, correct it. If it's math, do the math. A lot of times people confuse or mix up the conversion. They put 1 pound as 2.2 kilograms. I see that every semester. Josh, so the weight conversion, right? So make sure you remember 1 kilogram is 2.2 pounds. All right, let's do one more of this. Let's find where the error was for some. All right, so the doctor orders a medication for 10 a.m. The nurse should give 25 micrograms per kilogram. That's 2-factor. Patient weighs 200 pounds. Pharmacy sends something in micrograms because they're mean. What am I going to give? Well, they sent something that's available in milliliters, so that's what I'm going to give, milliliters. Cool. So I've used this. I know I need a conversion. So, oh no, I don't need a conversion. It's in micrograms. Yay. Oops. Okay. So, how do I get rid of micrograms? I'm going to use my problem. 900 micrograms in 5 milliliters. That's what pharmacy said, and that's what I'm going to use. So I have the milliliters. Yay. But I have to get rid of kilograms. How do I get rid of kilograms? I got to do my conversions. So the patient's weight is in pounds, so I need the pound to weight conversion. 1 kilogram is equal to 2.2 pounds. So I'm going to use that to get rid of kilograms. 1 kilogram is 2.2 pounds. That erases my kilogram. Now I have to get rid of pounds. I'm going to use the patient's weight, which is 200 pounds. I'm going to put 200 pounds up here so I can get rid of it, cross off diagonally. And that leaves me with everything crossed off but my milliliters. I always look at my problem, make sure there's nothing left. These are all crossed off. Gorgeous. I love it. Now it's just math, right? So let's do the math. 25 times 5 times 200. You always start your dimensional analysis with a number that has no unit in the denominator. So so in this case, 200 pounds. Listen, how you set it up, I'm okay with. I know some people learn a different way. Just don't screw up the unit of measure. It's not worth the 5 points. I always maintain consistency in it because when we get to 3-factor, it gets a little squirrely. But yeah, if your answer ends up the right answer, however you set it up is up to you. I just have to teach the dimensional analysis. So when I do the math, 25 times 5 times 200, it gives me 25,000, and then 900 times 2.2 is 1980. And when I divide that, it gives me 12.6262, and it keeps going, keeps going. So anything 10 and up, I round to the whole number. I look to the number to the right, it's 6. That means it's higher than 5. So 6 and up, I round up. So the answer is 13 milliliters. Boom, 2-factor done. All right. So 2-factor, if I was creating a test, it would include pounds to kilogram conversions, and it would include all the conversions. So I know you can practice safely for sure. All right. So let's move on to 3-factor. I'm just going to pause for a second. All right, let's talk IVs. I love me some IVs. So these are just example of types of IV bags you'll come across in your practice. This happens to be 1,000 milliliter bag of normal saline. And this is just 500 milliliters of normal saline. This is a smaller bag. This one has 250 milliliters, and these are little 50 milliliter bags. So we use these for all different things. We give fluids to the patients using larger volumes, and then we tend to use the smaller bags for medications, antibiotics, cardiac meds. So we use these to administer smaller doses of medications or to mix medications to give to our patients. But as you notice, these are all in milliliters. But how do we give these fluids? Well, there's 2 ways we're going to give fluids, and it really depends where you work. So if you're blessed to work in a facility that has IV pumps, because not every place has IV pumps, you're going to use a machine, something like this. And the only way to administer medications is milliliters per hour, if it's volume, or strength per hour. So milliliters per hour is for pump. I just want you to keep that in mind. But some places don't have pumps, like the nursing homes. So we go to Pine Valley for 118 and they use something called a drop factor. And it's special tubing that has a little dial on it. And it literally tells you how many drops the patient will get every minute. So if we're not using a pump, we're using gravity, and that's called the drop factor. That's called drops per minute. So it's either pump or gravity. So milliliters an hour or drops per minute. And that's the only two ways you're going to be asked the question. All right. So let's start with how sorry, I didn't finish my spiel. So pump tubing and gravity tubing look the same. Pump tubing, though, does have a certain chamber. So it's like a special tubing that does go in through this chamber here. Gravity tubing does not. But I want you to notice that no matter what one you use, there's this little thing called the drop factor, and it's available on every IV tubing. So I don't know if you can see that. So right here, it says this may be made for the IV pump, but it does give you something called the drop factor. And you might be thinking, why? If it goes to the pump, I don't need to know drops. Well, guess what? Pumps fail. Pumps fail all the time. So you might have to convert and use drops. Here's another example. This one is 15 drops per milliliter. 15 drops per milliliter. This one, 10 drops per milliliter. Oh, okay. So I just wanted to show you that real quick. And you should have seen that in the PowerPoints. So here's the first question. So this is how I want you to approach IV fluid questions. The doctor orders 1,000 milliliters of half normal saline. He wants it to run over 6 hours via a pump. What is the infusion rate? What is the flow rate? There's many ways we can ask the question. So we have to look for something. This is a two-factor if you think about it. There's two parts to the order. He wants you to give 1,000 milliliters over a specific time, volume over time. That's a two-factor. So when you see this question, I want you to first look for one word in every question, and that is the word pump. If your question says pump and it asks you the flow rate, you are always solving for milliliters an hour. Always, always, always. So then how do I start the problem? Like you do every other two-factor. I have to give 1,000 milliliters in 6 hours. Volume over time. Well, I need milliliters in my numerator, and I have it. I need hours in my denominator. I have it. Wait, could it be that easy? Yes. Yes, it could be. So all I need to do is divide 6 into 1,000. So how many milliliters an hour am I giving? And Francine came in. Yeah, Jancy said 167 with Francine. We're going to give, because when you divide 6 into 1,000 in your calculator, it'll say 1.66666. Anything greater than 10, we round to the whole number. I'm going to set my IV pump at 167 milliliters an hour. So what does that mean? I'm going to go in here. I'm going to put my tubing in there, connect it to my IV. And then I'm going to program my pump and write 167 and hit enter. And it's going to automatically deliver 167 milliliters an hour. That's what that means. So it says the word pump. So do this question. You got it. No tricks up my sleeve here. It's just about you reading the question. The doctor orders 1 liter of normal saline over 8 hours. What is the infusion rate you're setting on the pump? It has a pump. I got pump. So I'm solving milliliters an hour. Milliliter in my numerator, hour in my denominator. So volume over time, 1 liter. Well, you can do a whole conversion, but you should know 1 liter is 1,000 milliliters. Over 8 hours. 8 divided into 1,000 is 125 milliliters an hour, because I already have milliliters an hour in the numerator and denominator. If you wanted to start with 1 liter, that's okay too. So it's 1 liter over, you can convert it first, 1 liter, and I can say 1 liter is 1,000 milliliters. Cross off my liters, and it tells me when I do my math that it's 1,000 milliliters. If you didn't remember, go through the steps. I don't care. Just to give the patient the right med, do as many steps as you need to be safe. and to get the answer right. So yes, 125 milliliters an hour. What about this one? Yes, so I look at the question, I read the question. The doctor orders 1.5 liters of D5W. We have to give that to the patient over a 12-hour shift. What is the flow rate you would set on the IV pump? Drop factor 10. If I got the word pump in my problem, that means I have a machine. It's always milliliters an hour. That means I don't need the drop factor. That's that special tubing for gravity. Milliliters an hour. So what's my volume over time? 1.5 liters is 1,500 milliliters. And I need to give it over 12 hours. So I need milliliter in the numerator. I got it. Hour in the denominator. Got it. 12 divided into 1,500-ish. 125 milliliters per hour. And that's what you're going to write on the answer line. Beautiful. Do this one. Perfect. You didn't get frazzled and dazzled because it's telling you this 1,000 milliliters of D5W has to be given over 12 hours, and it just so happens to have medication in it. What's the infusion rate? What's the flow rate? Well, how do I know I'm solving for a pump? It doesn't say the word pump. Anybody want to guess? Right on, Stephanie. It doesn't say drop factor either, so I can only use what I got. I got to give 1,000 milliliters over 12 hours. I don't care about the strength. It didn't ask me about the potassium medication or how much milliequivalents I'm giving. It's asking me flow rate. So if I don't have a drop factor or anything like that, it's milliliters an hour. So it's 1,000 milliliters divided by 12. And that will still give me, I'm sorry, is it 12? Oh, yeah. It will still give me 83. It'll come out to be 83.33. 10 and up, we round whole number. That's 83 milliliters an hour. All right, so that's a pump. All right, so let's move on to not a pump. Let me see. Oh, let me do a smaller volume for you. All right, solve for this one. All right, you guys are rocking and rolling through this one. I love it. So you're not getting razzled and frazzled. I love it. Volume over time. The doctor needs you to give a medication. It comes in an IV Soluset, a little bag, a little 50 milliliter bag. It happens to have probably antibiotic in it. I don't know. So it has medicine in it, but you have to give 50 milliliters in 45 minutes because it's asking you the flow rate, and you got to pump. So if I got a pump and it wants flow rate, it's milliliters an hour, and I always start volume over time, 50 milliliters in 45 minutes. So what do I got to do? I got some work to do. I have milliliters in my numerator. I'm good, but I got to change minutes to hour. I can do that. There's 60 minutes in 1 hour. That gets rid of my minutes, and it leaves me with hour. So I have milliliters an hour. Now it's just math. So 50 times 6 is 3,000. And 45 times 1 is 45. And when I divide that into each other, it gets 66.66. A whole number, look to the right, 5 and up, I round up. So I'm going to set the IV pump to go at 67 milliliters an hour. Beautiful. I'm going to pause for this one. I love it. I love it. You're not getting razzled. I love it. So the doctor orders 1,500 units an hour. You're going to be given heparin all the time in your clinical practice when you're working as a nurse. 1,500 units per hour. So this is not, it's a volume. It's a unit of measure as well. You have to get 1,500 units, and we're using a pump. And it's telling you, what are you going to set it at? It's giving you the wanted milliliters an hour. So I know I'm using milliliters an hour, and I'm giving, the doctor orders 1,500 units of heparin every hour. You don't want to mess with heparin and make an error with this calculation because heparin is a blood thinner. So if you overdose a patient on heparin, they can have bleeding in their brain, bleeding in their colon, bleeding in their lungs. They can bleed everywhere inside their body. So it's very important you understand this, okay? So I know where I'm starting. The doctor's order 2-factor, 1,500 units an hour, and I know where I'm going. Milliliters an hour. Got it. I got the hour. I'm good. How do I get rid of units and get to milliliters? All right, I'm going to look at my problem. Pharmacy sent me something. I'm liking it. 25,000 units and 250 milliliters. I'm using it. So 25,000 units in 250 milliliters. Beautiful. Gets rid of my units. I'm left with milliliters. Let's do some math. You can cross off zeros. 1, 2, 1, 2. You can even do an extra one. 1, 1. Let's do it. 15 times 25. If I wanted to do short math, I gotta use my calculator. Is 375, and 25 times 1 or nothing is 25. And then I divide that, and it'll give me 15 milliliters an hour. That's what I'm setting my pump at. Beautiful. Love it. All right. Do this one. Do this one together. Okay. No worries. I'm reading the question. A patient is to receive 500 milliliters over 4 hours. Volume over time. That's the doctor's order. 500 milliliters over 4 hours. The drop factor is 20 drops a milliliter. What is the flow rate? What is missing from this question? There's no pump. And they gave me a drop factor. So I'm solving for what? Drops per minute. That's the difference. That's the total difference between the IVs. It doesn't say the word pump, and it gives me a drop factor. Not a problem. It doesn't matter where you start. How do I change hours to minute? I got that. There's 1 hour is 60 minutes. Okay. Got rid of my hours and I got my minutes. One problem part done. Great. How do I get rid of milliliters and get to drops? Well, look to my question. I've already used the 500. I've already used the 4 hours. I don't have a pump. I'm solving for drops per minute. The only thing I haven't used is the drop factor, 20 drops per milliliter. I'm going to use it. So 20 drops per milliliter. Cross off my milliliter and it leaves me with drops. That's it. Everything else is gone. Drops in the numerator, minutes in the denominator. Now it's just math. So when I do across the top, 500 times 20 is 10,000. And 60 times 4 is 240. And when I divide, it'll give me 41.66, which I round a whole number to the whole number. If it's greater than 10, it'll give me 42 drops per minute. Do this one. All right, you guys are impressing me every minute of the minutes, the days. I love it. Let's start it. A patient is to receive 200 milliliters over 4 hours. The doctor's order, volume over time, 200 milliliters over 4 hours. Drop factor 10. What is the drop rate? There is no pump, but I got a drop factor. Okay, I'm solving for drops per minute. Feeling confident. I got this. So, what do I get rid of first? Well, let's get rid of hours and change it to minute. 1 hour is 60 minutes. Okay. I have minutes. Beautiful. How do I get rid of milliliters? Well, I've used this. I've used this. I know it's no pump. I'm using, the drop factor. So drop factor 10. What does that mean? 10 drops per milliliter. If it said drop factor 8, it's 8 drops per milliliter. If it said drop factor 20, it's 20 drops per milliliter. This one says 10, so it's 10 drops per milliliter. So I'm using it. I got to get rid of milliliters. I need drops. So I do 10 drops per milliliter. Cross off my milliliters. Now I'm left with drops in my numerator, minutes in my denominator. Everything else is crossed off and feeling good. Now it's just math. So 200 times 10 is 2,000. And 4 times 60 times 1 is 240. And when I divide, it'll give me 8.33. Well, how do I split that little drop? I can't. You can't split drops. So this is one of those one-offs, like capsules. I can't split a capsule. Well, I can't split a drop. So the answer, you got to round it to a whole number. So look at the 3, look to the number to the right. If it's not 5 and up, if it's under 5, you keep the number. So the answer is what? 8 drops per minute. Beautiful. All right. Do this one. All right, let's do it. What is the drip rate for an IV ordered? 1 liter per day with a drop factor of 8. So there is no pump. I got no pump. So 1 liter is 1,000 milliliters per day. There's 24 hours in a day, people. So there's no pump. I'm solving for drops per minute. I'm going to count drops every minute. So let's change hours. 1 hour is 60 minutes. Beautiful. I have minutes. How do I get rid of the milliliters and get drops? Use the drop factor. A drop factor of 8 is 8 drops per milliliter. 8 drops per milliliter. Beautiful. Gets rid of my milliliter. I have drops in my numerator. Life is good. I'm ready to solve. So 1,000 times 8 is 8,000. And 24 times 60 is 1440. And when I divide that, it'll give me 5.555. I can't split a drop. I'm not that good. 5 and up, I round up. So it's going to be set at 6 drops per minute. Beautiful. Love it. All right. Let me just see something. There's one more type you might come across. I'd say is this one. Solve for this. I think you guys are getting it. No pump in this question, and you got to know what a micro drip is. So micro drips is always 60 drops per milliliter. Don't ask me why these companies do this to us, but they do. It's all right. We're nurses. We adapt. So 1,500 milliliters to be given micro drip over 8 hours. And a micro drip is 60 drops per milliliter. No pump, so drops per minute. So same thing, 1 hour, 60 minutes. So that's why I say if you just keep doing these problems over and over, eventually you will have some good muscle memory. And I highly recommend watching all the final exam prep videos on the YouTube site as well. I'm not trying to get YouTube famous. It's just the only place that houses large volumes of videos. So when I do the math across, it's 90,000. And then 480, and when I divide, it gives me 187.5, which I round up to a whole number. 5 and up, I round up 188 drops per minute. All right, one more style. This we got to move on. I just got to check you and make sure you're not getting too squirrely on me here. So solve this. Let's do it. All right, the patient has to get 50 milligrams of something. IV Soluset in 50 milliliters of normal saline over 30 minutes. The drop factor is 10. What is the flow rate? So no pump. Positive drop factor. So it's drops per minute. Right? So I know it's the flow rate. I got a drop factor of 30. So volume over time, because it's asking me the flow rate. So it's 50 milliliters over 30 minutes. Well, look at that. I already have minutes. So I have to get rid of milliliters. So how do I get rid of milliliters? Well, I'm going to use my drop factor. 10 drops per milliliter. So now it's just math. So 50 times 10 will give me 500. And 30 times nothing or 1 is 30. And that will give me 16.66, which I round to the whole number. 0.6, 5 and up, round up. So it's 17 drops per minute. I want you to do this one. Questions, and you're going to have to keep practicing until the day of your exam. Girly, check your math, or it might just be a typo. So let's read this question. An IV pump is set to deliver 13 milliliters an hour. The IV solution is labeled 1 gram per 250 milliliters. How many milligrams an hour of medication is the patient receiving? So we know what they're asking us to solve for, milligrams an hour. I think we can identify that. Cool. The order, what's the order? Well, it's telling you to deliver 13 milliliters an hour, volume over time. Because what am I going to, the order is, this is telling you what's available. What is available, that's what it's labeled. So 13 milliliters an hour is your starting point. So I have hour, and I need to get rid of milliliter and get to milligram. All I have left that I haven't used is 1 gram and 250 milliliters. So you know you need a conversion, because the question that you're solving for is milligrams. So 1 gram is 1,000 milligrams. So how do I get rid of milliliters? Well, I'm first going to use what's in my problem. 1 gram in 250 milliliters. That crosses off my milliliters. How do I get rid of the gram? I use my conversion. 1 gram in 1,000 milligrams. That gets rid of my grams and it leaves me with milligrams. So now I have milligrams in my numerator, hours in my denominator. Everything else is crossed off. So now it's just math. So when I do the math, it's 13,000 over 250. When I divide, it will give me 52 milligrams an hour. Okay. So you're going to have to keep practicing these. Yes, you got it. Good. So keep practicing these types of questions. All the practice sheets have it. So let me just pause here. All right. So this is an example of a 3-factor. So we're going to do this one together. So what does it mean 3-factor? Well, it just basically means there's 3 elements to the order. The dose, we're identifying weight and time. That's all that means. 3 elements to the order. So 3-factor, we start with the doctor's order. 0.3 milligrams over kilograms per day. That's how you start a 3-factor. 0.3 milligrams per kilogram per day. I've used it. What is the correct daily dose for the patient who weighs 68 pounds? So I need to solve for daily dose. Daily dose. So I need the dose over day. And what's the dose? Well, it's the milligrams. So how many milligrams per day are you giving this patient? All right. So let's start solving. We already have the first one, milligrams. And I have the word day here. The only thing I need to get rid of now is what? Kilograms. How am I going to get rid of kilograms? Oh, the patient's weight. But the weight is in pounds. So my conversion. 1 kilogram is 2.2 pounds, and the patient weighs 68 pounds. I put that over 1 because I need everything balanced. I cross off all my unwanted, and now it's just math. 0.3 times 68 is 20.4, and 2.2 times 1 is 2.2, and when I divide 2.2 into 20.4, it will give me 9.2727. 1 to 10, I round to the tenths. I look to the number to the right. It's 5 and up, I round up. My answer will be 9.3 milligrams a day. Let's do this one together. The recommended dose for a medication is 8 milligrams per kilogram per day, 3-factor. 8 milligrams over kilogram per day. What should the daily dose be for an adult weighing 105 pounds? Daily dose. Every day, how many milligrams is the patient going to get? The daily dose. That's the only thing I can solve for. I have milligrams and I have day, so I just have to get rid of kilogram. But the patient's weight is in pounds. You can see how it's the same steps. 1 kilogram, 2.2 pounds times 105 pounds over 1. I cross off my unwanted, and now it's just math. So 8 times 105 times 1 will give me 840, and 2.2 times 1 is 2.2. When I divide that, it will give me 381.81. Anything over 10 and up, I round to a whole number. I look to the number to the right. 5 and up, I round up. So the answer is 382 milligrams a day. So what does this mean? Well, it basically is saying this patient who weighs 105 pounds, he should be getting this in a full day. If you notice as a nurse that the doctor's ordered 7,000 milligrams in a day, this is where having that knowledge of how to solve for these problems comes into play in your practice. So we're just teaching you the math elements of it, but you'll learn medications throughout the program. But this is why we're teaching you it. Right now, it may be like, why do I need to know this? This is crazy. But it's because it's patient safety. The recommended dose, somebody has recommended it, and it's from drug makers and the peer-reviewed studies that have been done that makes the drug safe. So that's why we do it this way. So I'm going to let you solve for this one. All right, so it's no trick questions here. It's 1 milligram per kilogram per day. What is the correct daily dose? So milligrams a day, and the patient weighs 105 pounds. It's the same setup. All right. So during your exam, just sit and look at the question, read the question. I promise you, it'll start to make sense someday. I don't know when. But 1 milligram, 1 times 1 times 105 is 105. And 2.2 times 1 or nothing is 2.2. And when you divide it, it'll give you 47.73. We round up to a whole number, and that would be 48 milligrams a day. Now, another way you will see the 3-factor written is this is per day, the whole day. They're going to get 48 milligrams. But what if I want to know per dose? So let's look at this question. The safe dose of a medication is 0.06 milligrams per kilogram per day. It's going to be given in 2 divided doses. That means the patient's going to get it twice a day. So maybe they're going to get it at 10A and 10P. Let's say 10A and 10P, right? That means 2 divided doses. 10 a.m. and 10 p.m. you're going to give this drug. The patient weighs 21 pounds. The medication comes labeled with what's in it. This is asking you something very specific. How many milliliters of the medication will the nurse give for the 2200 dose? We start with our given, our doctor's order. 0.06 milligrams per kilogram per day. It wants to know how many milliliters per dose the patient's going to get. All right. So I've used this. I've used milliliters. I know I'm solving for dose. It's now a process of elimination. So however you want to get rid of it is fine. But I like to start with the painfully obvious one that everybody forgets to do. How do I change the word day to dose? Every day, the patient is getting how many doses? 2 doses. I always start there when I'm solving for dose, so I don't forget. So now I have one part. Now, what do I want to get rid of next? Kilograms? Sure. Well, unfortunately, the patient's weight is in pounds. So 1 kilogram is 2.2 pounds, and the patient weighs 21 pounds. Great. Now I got to get milligrams to milliliters. What can I use in my problem? I've used everything except the 1 milligram per milliliter, and that's what I'm going to use. So 1 milliliter is 1 milligram, and I use it. Cross off my milligrams, and now I'm left with milliliters. I'm done. I'm ready to solve. Now it's just math. This setup is everything. So let's do the math, and it's gross, I know. So 0.6 times 21 is 1.26. I'm going to write it down here. And 2.2 times 2 is 4.4. When I divide that, it gives me 0.286. Anything less than 1, I round. Oops, what the heck is this thing doing? Anything less than 1, I round to the hundredths place. So I look to the number to the right, 5 and up, I round up. So the answer is, for the 10 p.m. dose, I'm going to draw up into a syringe 0.29 milliliters and give it to this 21-pound child. So you see how important it is. You have to be accurate and know how to solve for these problems. So let's do one. I'll pause for you to solve. You guys are definitely getting it. So those are the 2 ways you're going to see the 3-factor when it comes to daily dose and per dose. So you definitely need to know how to do that. So let's do this real quick. 24 milligrams per kilogram per day. The question is asking, in 3 divided doses, that's 3 times a day. The patient's weight is 55 kilograms. And pharmacy delivers it in grams because they just want to torture us, which is okay. But we have to calculate the dose you're going to give at 8 a.m. So I'm solving for what? How do I know? What am I going to give at 8 a.m.? You got to think about it. calculate the dose you're going to give at 8 a.m. Well, am I giving a dose or am I giving what am I giving? Oh, I have to give milliliters. That's how it comes. What am I going to give milliliters for that dose at 8 a.m.? Because it comes in a liquid. So let's do it. What do you want to get rid of? I want to get rid of day. Every day there's 3 doses. Yay. Cross it off. I used it, got rid of day. I have my word dose. I want to get rid of kilogram. Oh, thank you. It's in kilograms. 55 kilograms over 1. Yay, it gets rid of kilograms. Beautiful. Used it. Now I have to get rid of milligrams and get to milliliters, but this is in grams, so I need a conversion. 1 gram is 1,000 milligrams. So I'm going to use it. 1 gram is 1,000 milligrams. Gets rid of milligrams. Now I have grams. Yay. But I have to get rid of it. How do I get rid of it? I use what's in my problem. So 0.65 grams per 2 ml. Gets rid of my grams, and I'm left with milliliters. Yay. Now it's just math, because everything else has been crossed off. So the math is also just as gross, but 24 times 55 times 2 will give me 2640 over 3 times 1,000 times 0.65 will give me 1950. When I divide, it'll give me 1.3538. 1 to 10, I round to the tenths. If it's 5 and up, I round up. So I'm going to give 1.4 milliliters at the 8 a.m. dose. Okay, good. Here's another type of question you will see. So we'll do this one together real quick. Well, actually, let me pause because, yeah, I'm going to pause it and let you guys solve. Probably just a math error. All right, so you can see how everything we're learning is building and building on each other. So it's coming into big, long problems to solve. So again, just take your time setting it up. The doctor's order, it says administer 22 micrograms per kilogram per minute. This is a 3-factor, 3 elements: strength, weight, time. The setup is the same though. All right, the IV has a label, 500 milligrams and 500 milliliters. The patient has a weight, 120 pounds. The drop factor is 15. Calculate the infusion rate for the IV pump. Infusion rate, it's either milliliters an hour or drops per minute. Infusion rate, flow rate, drop rate. If it's infusion rate and you have a pump, it is milliliters an hour. That's what you're solving for. So pump, infusion rate, got it. Don't need the drop factor. Beautiful. I know where I'm starting. I know where I'm ending. Now I just got to get there. So what do you want to get rid of first? We can change minute to hour. Fine. 60 minutes in 1 hour. Got it. Beautiful. Now I have hour. How do I get rid of kilogram? The patient's weight is in pounds. Okay, no problem. 1 kilogram is 2.2 pounds. The patient weighs 120 pounds. Put that over 1, no problem. Got it. How do I get rid of micrograms? I've used everything. The only thing left is the label, which is in milligrams. So I need a conversion. 1 milligram is 1,000 micrograms. That gets rid of my micrograms. Now, how do I get rid of milligrams? I'm going to use my problem. 500 milligrams and 500 milliliters. Now, there's 100 ways you can cross off and do things. If you want to do it the long way is pretty disgusting. The answer is like 79,200,000 over 1,100,000. And then you divide and it will give you 72 milliliters an hour. Or you can cross off like amounts. 500 and 500 cancel each other out. You can remove zeros if you want to. 1 0 here, 1 0 there. Make sure you take off 2 from the top, 2 from the bottom. So you can solve different ways, but if you have a calculator, use it. If you enter the numbers and it gives you an error message, then you have to cross off zeros. All right, I'm just saying. But use the calculator if you have it. But the answer for this one is 72 milliliters an hour. Oh, it was a typo. Good. So look at your problem that you solved and try to find out where you made that error. So this one started with a 3-factor problem. This one asks you to solve for 3-factor. Now you can see we're running out of time. All right, but I want to do this one with you real quick. an IV medication of 100 milligrams in 250 milliliters of normal saline is already infusing into the patient at 75 milliliters an hour via an IV pump. The patient's already getting it. They want you to solve how many micrograms per kilogram a minute of medication is this 110-pound patient getting. We're talking about cardiac meds here. Now we're doing high-level solving, but this is what you're going to do depending on where you work. So if I know what my wanted is, how many micrograms, and it's a three-factor, we always write it the same, per kilogram per minute, strength, weight, time. That means in my numerator, I need micrograms. In my denominator, I need kilograms and minutes. So I know what I'm solving for. Where do I start? I'm going to always start with my volume over time because that's what's running. That's the doctor's order, running at 75 milliliters an hour. So I'm going to start with 75 milliliters an hour. And if you can't remember that, at least look for the time on the bottom. You know you need time on the bottom in the denominator. So how do I get there? Well, let's change hour to minute first. 1 hour is 60 minutes. I cross it off. I have one part. How do I get kilogram in my denominator? I mean, I got a patient weight, but it's in pounds. I'm going to write it backwards. 1 kilogram is 2.2 pounds. I'm a nurse. This is nurse math. So I have kilogram. Beautiful. But now how do I get rid of pounds? I'm going to use the patient's weight. But now remember, I have to put it across diagonally to cross it off. So I mean, I'm going to write it down in the bottom. 110 pounds. And I'm going to put a 1 over it. I'm going to cross off my pounds. All right, I'm doing it. I'm getting there. Now, how do I get rid of milliliter and get the micrograms? Well, the only thing I haven't used in my problem is the concentration. So I'm going to use it. There's 100 milligrams in 250 milliliters. That gets rid of my milliliters. Now I have to get rid of my micrograms. But how do I do that? Conversion. 1 milligram is equal to 1,000 micrograms, right? So I'm going to use it. 1 milligram is 1,000 micrograms. And after I cross everything off, I have micrograms in my numerator and kilograms per minute in my denominator. And it's weird and everybody feels weird doing it, but it's nurse math. And this is how we solve for our problems for calculations. So now it's just math. Crazy math, but it's still math. So we're going to do 75 times 100 times 1,000 times 10.2 times 1. Anyway, it's going to give us, I mean, like 16,500,000. And then I'm going to do 250 times 60 times 110 times 250, and that's going to give me 1,650,000. Then I'm going to divide, and it's going to give me ultimately 10 micrograms per kilogram per minute. Boom! And you were probably giving a nitro drip or a cardine drip or some crazy cardiac med drip. But that's how you do the reverse, 3-factor reverse. All right, so just watch this over, or definitely go to the YouTube site and watch the final prep that has these practice questions in it, how to solve. So this was a 2-factor, 2 elements to an order that went to a 3-factor. So this is high level. All right, but good for you guys getting it. I love it. So let me find one for you guys to try. I might not have it on this one. No, I don't have it on this one. All right, let me pause here for 1 second. All right, I want to ask you to look at this first question. This is just a prep for you guys to try. Just gonna find it. If I were to ask you and say the current time is 1400, that's military time, right? The IV will infuse over 3.45 hours. What time will the IV finish? All right. Good. Stephanie got it. Okay. All right, so I'm seeing a lot of different answers. I've seen a lot of the right answers. The actual answer is 17. Hold on. No. Well, we'll do it together, actually. Give me 1 second. So the current time is 1400, and it takes 3.45 hours to infuse. A lot of people will just say 1400 times 3.45. So 3 hours and 45 minutes. So they'll do 3, and they'll say it's 4, 5, 6, 1745. But we're talking about time. So I just wanted to review this with you real quick. When we talk about 3 hours and 3.45, when we have a number like 3.45, the 3 represents hours. The 0.45 represents time, but not the time that you think of. And if you are able to go and look at that PowerPoint to review it in detail, you basically have to take 0.45 and multiply it by 60 to get the right answer. When you multiply 0.45, because there's no such thing as 0.45 in minutes, but there are 60 minutes. That's why you multiply 0.45 times 60. And that will actually give you 27 minutes. So whenever you see something that says 3.45 or 2.45, the 3 represents hours, 3 hours. The 0.45 has to be multiplied by 60, or point whatever has to be multiplied by 60. And in this case, it's 27 minutes. So when I ask you again, what's 1400 plus 3 hours and 27 minutes, the actual answer is 17, even I'm having a brain freeze. I'm getting tired. Sorry. 1727. And Esther, I noticed one thing I'm glad you did that. I'm not glad that you did that, but when you write military time, you do not use the colon. Military time has no colon. So 1727 is the correct answer. Yes, girly.
I'm sorry, you're going too fast.
Okay.
I don't understand why you had said the 0.45 is not considered minutes. It considered time. Can you just
Yeah, it'll make sense when we do the problem. This is just like a tester, just to introduce it to you. So look at this one real quick. The current time is 20:05.
That's 8:05.
All right. So I'm saying the IV will infuse for 2.28 hours. 2.28 hours. Okay. It's only hours. So when you see 2.28, anything before the decimal is hours. All right. But anything after is minutes. But there's no such thing as 0.28 minutes. It's not a full minute. You have to multiply it by 60, anything after the decimal. So when we do 0.28 times 60, it will give you 16.8, and we round up to 17. So it's actually 2 hours and 17 minutes. And I'm going to show you why when we do the problem. So the answer to this one is, what time will the IV finish? The exact time? 22:22. So let's do the problems so you understand what I'm talking about. Where is it? Nope, that's not. Okay. If you did the review, I want you to solve this. I'll give you a minute or two. All right, so let's do this real quick. So I'm going to give you my scenario. This is the scenario I use in class. So there's an IV of 550 milliliters that's already running at 15 drops a minute. It's already running. All right, the drop factor is 20 milliliters an hour. But at 1700, I walk into the patient's room and the IV only has 300 milliliters left in it. I got a different answer, Carmen. It only has 300 milliliters left in the bag. And I need to know what time it's going to finish because I need to know when I need to come back with a brand new IV bag so it doesn't go dry. So at 1700, I walk in the room and there's only 300 milliliters left in the bag. So I start with what's left in the bag, 300 milliliters. I always put everything over one. I don't like blank spaces. So what am I solving for? Well, I'm solving for time. So I'm solving for hours. I'm going to say hour. Oops. So I'm solving for time. So hours. So how do I get rid of milliliters and make my way towards hours? Well, I've already used this part of my problem. I know I'm solving for time. So how do I get rid of milliliters? Well, I'm going to look at my problem. And in my problem, there's 20 drops per milliliter. All right, that gets rid of my milliliters. So I'm going to cross it off. Now, how do I get rid of drops? Well, I'm going to use what's in my problems. I'm going to go, there's 15 drops per minute. That gets rid of my drops. So now how do I change minute to hour? I got this. 1 hour is 60 minutes. So you see this process of elimination. So now I'm left with hour in my numerator. So now I do the math. And this is where it might make sense about the point making minutes. So when I do the math, 300 times 20 times 1 is 6,000. And 15 times 60 is 900. And when I divide 900 into 60, it'll give me an answer 6.666666. Everything before the decimal is hours. 6 hours. The 0.66666 represents minutes, but I don't know minutes as 0.66666. Okay. So now I have to multiply, and I always recommend going out at least 6 digits. I multiply 0.666666 times 60. And when I do that, it'll give me 39.99. I use my rounding rules. 39 is a whole number, so I round it up to 40. So now I have 6 hours and 40 minutes. That's how long it's going to take that 300 milliliters to run. But the question said, what time do I need to go back in with a new IV bag? What time? Well, I walked in at 1700, right? And if it's going to take 6 hours and 40 minutes for it to infuse into the patient, I need to go back in at what? 2340 with a brand new IV bag to hang for that patient. So this question said, what time will the IV finish? What time do I have to go back in there to make sure that fluid doesn't go empty on that patient, that they're not getting air in their veins or whatever dramatic reason you can remember it? All right. So that's why you have to understand that when you have a decimal, anything after the decimal represents minutes, you have to solve it by using 60 minutes. So now I want you to do this one. I'm going to give you a few minutes to solve. Let's do it. All right, an IV, 500 milliliters that I hung up original bag of 500 milliliters and it's been running at 10 drops a minute. Awesome. But I walk in at 1400. Professor K walks in the room and there's only 300 milliliters left in the bag. So we always start with left in the bag, 300 milliliters. Put it over 1. What time will it finish? The exact time. So I'm solving for hours. I put that over 1. Beautiful. Let's break it down. Let's get rid of the unwanted. So I get rid of milliliters by using 15 drops per milliliter. I cross off my milliliters. Now, how do I get rid of drops? I'm going to use my problem. 10 drops per minute. Beautiful. Cross off my minutes. Now, how do I get minutes to hours? Not a problem. 1 hour is 60 minutes. Give me a challenge, Professor. Come on. That leaves me with hours. So now it's just math. I've crossed off everything I don't need. So when I do 300 times 15 times 1, it'll give me 4,500. And then 10 times 60 is 600. And when I divide, it'll give me, hold on a second. I just want to double check something. I think I found my own typo here. Usually you guys help me with that. 4,500 divided by 600. Okay, so it'll give me 7.5. So anything before the decimal is hours, 7 hours. So 0.5 represents minutes. I don't know 0.5 minutes. So 0.5 times 60 is 30. 0.5 times 60, oops, sorry, is 30. So 7 hours and 30 minutes. Well, I walked in at 1400 and I have to go back in 7 hours and 30 minutes so the IV doesn't go dry. And that will give me a grand total of 2130. I'm going to walk back in that room with a brand new bag at 2130. Beautiful. Love it. All right, hold on one. So I'm going to now, let's see. Now I know we're close to the end, but I have no problem continuing for a little bit over. So, as I said, if you have to log off, no problem. But as I said, if you go to that YouTube site and watch the final prep videos, pause it, go through it, keep doing it over and over, it'll really expose you to the content that you could very well come across on the exam. So it covers everything. You have access to all those PowerPoints and videos. And I know the exam is next week's, but how many questions? There's 20 questions, 5 points each. Is there a list of acceptable calculators for the exam? It's got to be no more than a 25 button. Can't be scientific. And if you don't have a basic calculator, like I usually get mine on Amazon, but even Staples, this is my Staples basic. I don't know if you can see it. It's just a basic 25 button calculator, nothing fancy. And if they don't like the calculator, you bring to the testing center, they'll give you one. Is it pen and paper exam? Absolutely, because I got to see all your work. If you don't show me your work, you get 0 points. Partial credit? No partial credit. The one thing we didn't go over today was intake and output. We just wouldn't have enough time. 20 questions total. Scrap paper? No, you're going to write on the exam. So make sure you review your intake and output. Actually, we can review one. What you might see. Hold on. We will continue to need the basic calculator. Yes, they won't let you in with a scientific calculator. No way. I mean, there's so many new fancy things. People, I mean, half of them have digital information in it. So that's why it's got to be a basic one. If you don't have one, you don't have to go out and buy one. They'll let you borrow one. All right. So we didn't review intake and output, but we can do this one together real quick, just so you know what to expect. So here's an example of a classic intake and output question for the exams. And this goes on throughout your nursing semesters. So let's look at this question together. What is the total intake and output in milliliters for a patient who over the past 8 hours has received an IV solution of 125 milliliters an hour? They had 1.5 pints of juice, 2 1/4 glasses of milk, and 1 cup of coffee. And then their drained 123 milliliters of some kind of body fluid. They urinated 1,020 milliliters of urine, and then they vomited. Emesis means throwing up, vomit, 75 milliliters. So this is testing your knowledge about terminology as well as what's considered input and output. So let's start with the output. Output, it's asking you to tell me the total intake and output. It's always 2 numbers. Do not give me one giant number. It's wrong if you do that, okay? What went in the patient and what came out of the patient is what we need, because that tells us fluid balance. If I drink 40 ounces of water, 40 ounces of urine should come out of me. Ideally, it may not be identical, a perfect match, but somewhere around that within 100 milliliters, because I'm a healthy person. What I drink in should come out. But when patients are not healthy, and that's why they're patients, we monitor their intake and output because it tells us their fluid balance. Are they dehydrated? Are they overhydrated? Are their kidneys failing? It's so many things we can tell from intake and output. So it's always 2 numbers. Don't combine the 2. So what in this question counts as output? Tell me. You can say it. Yes, urine drainage, emesis, diarrhea, if it's liquid stool. So yes, this counts, it's drainage. This counts, it's urine, it's liquid. This counts, they threw up. We got to measure it all. So what's counted as input? Well, don't forget the IV fluids going in their body counts. What they drank. What if it said broth? It's liquid. What if it said ice cream? If it melts at room temperature, it's liquid. Jello is liquid. Ice pop is liquid. So these are things you have to understand for intake and output. But this is the type of question, so let's do it together. So let's start with output. This is how I did it when I was in school. I wrote output, 123 milliliters. Yes, something drained from the patient. Then they urinated. Yes, that counts. And then they vomited. Yes, that counts. So I take all these things and then I add it together. And that will give me 1,218 milliliters. I add everything together, 123 plus 1020 plus 75. My output is, and that's how I would write it, output. 1,218 milliliters. Beautiful. Now, what's my input? Well, the patient has been getting an IV of 125 milliliters an hour. How long have we been tracking this on this patient? Right on. The question said for 8 hours. So 125 milliliters times 8 is 1,000 milliliters. So this is my intake or input. So I have 1,000 milliliters. And I'm big on crossing off what I use because I don't like to get distracted. If I see a squirrel run past the classroom, you've lost me, all right? So I've used my 1,000 milliliters. I've used all of this for my output. 1.5 pints of juice. Well, intake and output, you have to do in milliliters. So what's 1.5 pints? Well, you can write it as 1.5 pints. And this is where dimensional analysis comes in. 1 pint is how many milliliters? Oh, thank you, Charlotte. 480 milliliters. Cross off my pints. I have my milliliters. So 1.5 times 480 is 720 milliliters. All right, cool. Then they drank 2¼ glasses of milk. So 2¼ you can write as 2.25 glasses over 1. So what's my glass to milliliter conversion? 1 glass is what? Is Charlotte the only one here still? 240 milliliters. Thank you. I cross off my glasses, and 2.25 times 240 is 540 milliliters. Beautiful. 1 cup of coffee. 1 cup. 1 cup is how many milliliters? 240 milliliters. Thank you. And I can do this dimensional analysis all day. And the reason why we didn't go over intake and output, because it's just like the one factor. It's just conversions. So 1 times 240 is 240 milliliters. So what is this patient's intake? I add 1,000 plus 720 plus 540 plus 240, and that will give me, yes, 2,500 milliliters in, and only 1,218 milliliters out. So right now it doesn't mean much to you, but in practice you'd be like, what's going on, Miss Tuller? Why are you not putting out what you're putting in? Maybe you were sick and dehydrated, or maybe you're retaining urine. So this is why we do intake and output. But this is how you do intake and output. Always 2 numbers in and out, and always in milliliters. All right. Another question you will come across, I promise you will come across. I want you to solve this one on the screen. I'm going to pause it for a minute. It seems so simple, but it's not a trick. But people usually don't round it properly, or they leave off the unit of measure. And this is not an uncommon question a doctor will say. Wait, what did the patient get today? How many injections? What's the total dose? You have to solve that. So yes, you're basically taking 0.678 milligrams, and the patient had 4 injections times 4, because they want to know what was the total amount the patient received for the day. Well, the patient had 4 injections, and this is what they were getting. So you multiply 0.678 times 4 doses, and that will give you 2.712, and then the rounding rules. 1 to 10, we round to the tenths. If it's not 5 and up, we don't round up. So the answer is 2.7 milligrams. Not a trick. Not a trick. Solve this one for me. All right, what did I say? We got to look at these questions. A patient is going to get 80 milligrams of a medication, IV piggyback, in a 50 milliliter bag of D5W over 15 minutes. The drop factor is 20. What is the flow rate? Well, what is not in this question? There ain't no pump, but we got a drop factor. So it's drops per minute. Yeah. So volume over time, 50 milliliters over 15 minutes. Beautiful. So I got minutes. How do I get rid of milliliters, get to drops? No, use a drop factor. 20 drops per milliliter. Well, look at that. That's it. That's it. So now it's just math. So 50 times 20 is 1,000 over 15. When I divide it, it gives me 66.66. Anything over 10, I round to the whole number. It's greater than 5, so the answer is going to be 67 drops per minute. I can't split a drop. All right. What about this one? All right. So yeah, what are we talking about here? The doctor orders 1,000 milliliters of half normal saline. It's just a type of IV fluid over 8 hours via pump. It's got a pump and it wants the infusion rate, milliliters an hour all day. So it's 1,000 milliliters in 8 hours. That's a 2-factor order. So I already have hour and milliliter. It's just division. So 8 divided into 1,000 is 125 milliliters an hour. Beautiful. What about this one? All right, you guys got it. So 500 milliliters over 3 hours. What's the infusion rate? It's a pump. So it's just 3 divided into 500. It's 167. Well, 166.6, and you round it to 167 milliliters an hour. Good. Solve this one. Or set up. Let's do it. The doctor orders 2,500 micrograms. The label reads grams per milliliter. What am I going to give? Well, it's a 1-factor. The doctor ordered 2,500 micrograms. Put that over 1. What am I going to give? Well, it only comes in a liquid, so I'm going to give the milliliters over 1. Well, it's provided in grams, so I need a conversion. So 1 gram is 1,000 micrograms. Gets rid of my micrograms. Now, how do I get rid of grams? I'm going to use my problem. So 0.06 grams per 5 mL. That gets rid of my grams and it leaves me with milliliters in my numerator. Beautiful. So now I just have to do math. Now it's just math. So 2,500 times 1 times 1 times. Oh, wait, is that 5 or 2? Hold on. Let me do this math with you. I might have found my own error here. No, I just transcribed it wrong. Weird. All right, so that's 1,200. Hold on. Might as well correct it while I'm here. Bear with me. All right, so that's 12,500. And then we have 1,000 times 0.06. Sorry, bear with me. I'm having a little technical. Hold on 1 second. This one, because I have some major math errors here. Oh my gosh. I found my own error. And thank you for bearing with me. So I made an error that you guys will probably recognize right away. So the doctor ordered 2,500 micrograms. I have to give milliliters because that's how it comes. But what I did wrong was I didn't do all the steps of the conversion. And I'm surprised that I did this because I always talk about how you shouldn't do it. So I have to go from grams, what's available, to micrograms. But 1 gram is equal to 1,000 milligrams, and 1 milligram is equal to 1,000 micrograms. So I jumped ahead 2 steps without doing it properly. I have to remember that if I'm going from grams to micrograms, there's actually 2 conversions. So how do I get rid of micrograms? So it's going to be 1 milligram is 1,000 micrograms. That crosses off my micrograms. Now, how do I get rid of milligrams? 1 milligram is 1,000 I did it backwards again, everybody. Woo! I think I need a CAT scan. I'm getting tired. 1 milligram is 1,000 micrograms. And then 1 gram is 1,000 milligrams. Oh, God. So now how do I get rid of the grams? I use what's in my problem. So that's 0.06 grams per 5 ml. Do you guys see the error I made? And the people who got 208 milliliters, you did what I just did in the beginning. I forgot, I missed a complete step. All right. So now we do the math. So 2,500 times 5 will give me 12,500. And then 1,000 times 1,000 times 0.06 is, I don't even know. I got to check now. Now I'm afraid. It's 60,000. All right. Whew. So when I do the math, 60,000 into 12,500, it will give me 0.208. So what's the rules? Less than 1, I round to the hundredths. So I look to the right. So the answer is 0.21 milliliters. Sorry for screwing that up for you, but it's actually a good learning point. So when we're going grams to micrograms, there's actually 2 conversions to remember. So those of you that got 0.21 milliliters, good job. For those of you who got 208 milliliters, you did what I did. I skipped an entire conversion. So don't do what I do in this problem. Do it the right way. All right, do this one. All right. Ethan, just a rounding error, I believe. Just check your rounding, all right? So let's do it together. It's a 3-factor. The recommended dose, 9 milligrams per kilogram per day. What should the daily dose be? Well, the dose is in milligrams and every day. How many milligrams a day? No problem. So I got that. I got a patient weight and I use this. So it just matter what you want to get rid of first. I need the word day and I need the milligram. Oops. So no problem. I just got to get rid of the kilogram. That's all that means. So 1 kilogram is 2.2 pounds, and the patient weighs 150 pounds. Over 1 gets rid of my pounds. I got rid of my kilograms. Now it's just math. So 9 times 150 is 1,350, and 2.2 times 1 is 2.2. When I divide it into each other, it gives me 613.63. So anything 10 over 10, we round to a whole number. So I look to the right, I round up. So the answer is 614 milligrams a day. You're very welcome, Josh. Head out. I'm going to post this as soon as the video is ready, but don't forget, go to the YouTube site, do those final exam prep questions, just do them over and over and keep practicing. You guys got this. All right, let's do another one. I got a few more minutes. Let's do this one. Cool, let's do it. The patient's to receive 100 milligrams of medication IV piggyback. It's in 100 milliliters, and you have to give it in 30 minutes. What is the infusion rate for the pump? I'm solving for a rate, and I got a pump. Positive pump means what? Milliliters an hour. So I have volume, 100 milliliters, over time, 30 minutes. So change minutes to hours. Okay, 60 minutes is 1 hour. Boom. Now it's just math, milliliters an hour. So 100 times 60 is 6,000. And 30 times 1 is 30. And when I divide that into each other, it will be 200 milliliters an hour is what I'm going to set my pump at to give my medication. What about this one? Well, let's do, yes, thank you, really. Let's do it. All right, the doctor ordered 2 liters per day. Drop factor of 12. There is no pump. No pump, and we got a drop factor. So I'm going with drops per minute. 2 liters, volume over time. 2 liters is 2,000 milliliters per day. Every day there's 24 hours. Boom. So let's change hours to minute. 1 hour is 60 minutes. Boop, boop, boop. How do I change milliliters to drops then? Because I have my minutes. Well, I got a drop factor of 12. And that means what? 12 drops per milliliter. So I'm going to use it. 12 drops per milliliter. Gets rid of my milliliters. Now I have drops in my numerator. I'm ready for math. So 2,000 times 12 is 24,000. And then 24 times 60 is 1440. When I divide it into each other, it'll give me 16.6. I can't split a drop. Whole number anyway, so I'm going to round to, I mean, a number over 10, I'm going to round up anyway. So the answer is 17 drops per minute. Gorgeous. Let's do this one. I'll go until 3:30, okay? So let's do this one. All right, I'm going to do this one. Oh, good, Ethan, good, yes. All right, so again, there's an IV that's already infusing at 55 drops a minute, but I walked in at 10 a.m. and there was only 550 milliliters left in the bag. I only start with what's left in the bag. That's what I care about. All right, so 550 milliliters was left in the bag, and I'm solving for what? Time, so I'm solving for hour. Put an hour over 1. So I used the 550. I walked in the room, only 550. What time do I go back in with a brand new bag so it doesn't go empty? That's what I'm solving for. So how do I get rid of milliliters? Well, I'm looking at my problem and drops per minute. No, oh, drop factor of 20. That means what? 20 drops per milliliter. So I'm going to use it. 20 drops per milliliter. That gets rid of my milliliters. Now, how do I get rid of my drops? I'm going to use my problem. 55 drops per minute. That gets rid of my drops. Beautiful. I've used it. Now, how do I get minute to hour? I know that one. 1 hour is 60 minutes. Oh, you put the 20. Oh, I got you, Carmen. So I'm left with hours. So everything else is crossed off. I'm ready to solve. So now it's math. So 550 times 20 times 1 is 1100, and 55 times 60 is 330. When I divide that, I will get 3.33333. Remember, I like to go out at least 5 or 6. So everything before the decimal is hours, so that's 3 hours. 0.33333 times 60, because 0.333 minutes does not exist. We have to multiply it by 60. So 0.333 times 60 will give me 19.99, which I will round to 20. So it's 3 hours and 20 minutes it will take that 550 milliliters to infuse. But it asked me what time will it finish. Well, I walked in at 10 a.m. and it's going to take 3 hours and 20 minutes. So that means I'm going back in the room at 13:20 with a brand new bag. I love it. Do this one. All right, let's do this one. Calculate the infusion rate. So I'm solving for some type of infusion rate of IV fluids to be given via micro drip over a 12-hour period. No word pump in this equation here. And I do have a drop factor and it's called micro drip. So I'm solving for drops per minute. So 1,000 milliliters over 12 hours. I'm going to change my hours to minutes. That gets rid of my hours and I have my minutes now. How do I get milliliters to drops? I'm going to use my micro drip. And if you remember, micro drip is what? 60 drops per milliliter. That gets rid of my milliliters and it leaves me with drops in my numerator. Beautiful. Now it's just math. So 1,000 times 60 is 60,000. And 12 times 60 is 720. And when I divide, it'll give me 83.33. I can't split a drop, plus it's over 10, so it's a whole number. I look to the right, so it's going to be 83 drops per minute. Do this one. 2 caps. Excellent. So yeah, let's go through it real quick because this will be the last one. So the order is 0.7 grams. They sent me something in milligrams and it's in capsules, so I'm going to give a capsule. I'm solving for capsules, right? So grams to milligrams, 1 gram is 1,000 milligrams. And there's 450 milligrams per capsule. So now it's just men. So 0.7 times 1,000 is 700. And 450 times 1 is 450. Now, when I divide that, it gives me 1.55. But I can't give 1.55 of a capsule. I either have to give 1 capsule or 2 capsules, right? I have to make a decision. So where does 1.55 land closer to? Well, 1.5 is right in the middle. So 1.55 is I'm leaning more to the 2, and that's the right answer. So the answer is I'm going to give my patient 2 capsules. Beautiful. Now, we did run out of time to go through the last things, but it's everything that we've already reviewed. So if you just look at any of the final preps, like week 13, in all the practice sheets, it's in there as well. No, you don't always round up for capsules, Esther. Great question. If the final answer was not 1.55, let's say the final answer was 1.35, you have to make a decision with a capsule, right? Either I'm giving 1 capsule or 2. Is 1.35 closer to 1 or to the 2? It's definitely closer to the 1. Do you understand that concept? Because in the middle is is half, 1.5. So 1.35 is closer to the 1. Okay, you got it. So please make sure you go to that site and watch those videos for the final prep. It has these same exact questions. We only didn't get to a few of them. But we did review all the content that will be on this exam. So I wish you all luck, but just go to that YouTube site, do those final preps, just keep doing it over and over until you sit for that exam. Trust your muscle memory for writing out these questions. I know you probably hear my annoying voice in your head. I apologize, but I want you to be successful, and thank you for working so hard and taking this challenge. I appreciate that. And after Wednesday, once everybody is done, I will be collecting the exams and I will grade them, and you should have the answers by either Thursday or Friday. It's pass or fail. You can't review the exam, but you will know if you passed or failed. All right. So good luck. Thank you for staying late with me. And as soon as Zoom saves this recording, I will post it in the Google Drive if it will allow me, but I will definitely post it with today's date in the YouTube site. But here's another little tip for you. If you know that certain problems take you longer to solve, remember it's on paper. You can flip through and go to the ones that you can do confidently and quickly, and then go back to the ones that take you longer. Maybe like intake and output, it takes you a little bit longer. This way you don't get stuck for a longer period of time, because remember, you only have an hour to do the exam. So if you're really good at solving things like, let's just say, I can solve this one factor from 0.25 milligrams, prepare. I start with the doctor's order, prepare this dose. If you know you can bang out these like within 30 seconds to a minute, do those first. All right. If you know you're good with reconstitution, do it first. All right. And if these type of IV questions take you longer, it's okay to skip because you're on paper. You can go back. Just don't forget to go back. All right. So good luck, and I'll see you in the semester. I'll talk to you soon. Bye-bye now.